Have you ever stared at an exam question, totally unsure of what the examiner actually wants? Yeah, we've all been there. In this explainer, we're going to break down a GCSE chemistry question, piece by piece, to show you exactly how to nail your answers and grab every single mark. So, the paper we're tackling today is the AQA GCSE Higher Tier Chemistry paper from June 2018. And the best way to understand what they're looking for is to look at the official mark scheme. Think of it like a secret cheat sheet. And today, we're going to crack the code together.
All right, let's zoom in on question 07. This one's a fantastic example because it tests two things: your basic recall and your ability to build a really detailed logical explanation about the halogens.
And here it is, the question in all its glory. As you can see, it's split into 3 different parts, worth a total of 7 marks, all about chlorine, iodine, and some of their compounds. Let's get into it.
So here's our game plan. We'll start with a quick recall question, then we'll dive deep into the 2 3-mark explanations, one on reactivity, one on structure. And to finish, we'll put it all together to see what a perfect, full-mark answer really looks like.
Let's kick things off with part 1. This is a nice little warm-up question, just a straightforward check to see if you've got the fundamentals down.
Okay, so the question is, what do you get when a chlorine solution reacts with potassium iodide solution? This is a textbook displacement reaction, right? You've got a more reactive halogen about to come in and push out a less reactive one. So what exactly does the mark scheme want for that one point? And there it is. The mark scheme is looking for potassium chloride and iodine. That's it. It makes sense, right? The more reactive chlorine just kicks the iodine out of the potassium iodide, forming potassium chloride and leaving poor iodine all by itself.
Now this is actually super helpful to see. The mark scheme shows you have some flexibility. You can use the correct chemical symbols, KCl and I2, and that's totally fine. You can even list them in any order you want, so iodine and potassium chloride works just as well. Good to know.
Okay, on to part 2, reactivity. Now things get a little trickier. This is an explanation question worth 3 marks, which is a big clue that you need to make 3 clear, separate, logical points to get full credit.
So the question is, explain why chlorine is more reactive than iodine. To answer this, you have to think all the way down to the atomic level. It's all about their structure. Let's walk through the perfect 3-step logic.
This right here is the golden structure for your answer. Step 1. State the simple fact. Chlorine's outer electron shell is closer to its nucleus. Step 2, explain what that means. Because it's closer, the positive nucleus has a stronger pull on those outer electrons. And finally, step 3, bring it home. That stronger attraction makes it easier for chlorine to gain an electron, which is what halogen reactivity is all about.
Now this is where it gets really interesting. For that first mark, the mark scheme actually allows a few different ways of saying the same thing. You could say chlorine has fewer shells, or the chlorine atom is smaller. You could even say chlorine has less shielding, which just means fewer inner electrons getting in the way of the nucleus's pull. But look at what they ignore: fewer outer shells. That's not precise enough. It just goes to show your wording really matters.
Your second mark hinges on making this exact connection. It's not quite enough to just say the atom is smaller. You have to explicitly link that fact to the consequence, that the nucleus has a greater attraction for outer electrons. That's the scientific principle they're testing.
And to lock in that third and final mark, you just complete the chain of logic. That stronger attraction means it's easier for the atom to gain an electron. Boom! You've shown you understand the entire process from start to finish.
All right, on to the final part of question 07, which is all about structure. And you guessed it, it's another 3-mark explanation. So we are once again looking for that clear 3-step argument. So, you're asked to explain why hydrogen chloride is a gas at room temperature. But look closely. The question gives you a massive hint. Answer in terms of structure and bonding. They are telling you exactly what to talk about.
And here is the exact 3-point logic the examiner is looking for. First, what's the structure? Hydrogen chloride is made of simple small molecules. Second, what are the forces between these molecules? Well, they're weak intermolecular forces. And third, connect that to energy. These weak forces need just a little bit of energy to be overcome. Okay, pay attention, because this is a huge trap that so many people fall into. You have to be crystal clear that you're talking about the weak forces between the molecules. When hydrogen chloride boils and turns into a gas, you are absolutely not breaking the strong covalent bonds inside the molecules. You're only overcoming the weak attractions holding one molecule to its neighbor. Getting this distinction right is crucial.
And that final point is the knockout punch. Because those forces between the molecules are weak, it doesn't take much energy to push them apart. And if it doesn't take much energy, that means it has a low boiling point, which is exactly why it's a gas at room temperature.
So, we've picked it apart piece by piece. Now let's put it all back together and just quickly review the core logic you need for a perfect 7 out of 7 answer.
This table is basically your blueprint. Part 1 is simple displacement. Part 2 is that chain reaction. Closer shell means greater attraction, which means it's easier to gain an electron. And part 3 is the other chain reaction. Small molecules have weak intermolecular forces, which need little energy to overcome. See the pattern?
Honestly, if you take one thing away from this, let it be this: precision is everything. The gap between a pretty good answer and a full-mark answer often comes down to just a couple of key scientific terms, like using intermolecular forces instead of just bonds, or nuclear attraction instead of a vague word like pull. And that's how you deconstruct an exam question to make sure you're getting every possible mark. But the real test is whether you can apply this thinking yourself. So using the exact same logic we just walked through, how would you explain why fluorine is even more reactive than chlorine? Have a think about it.